All right, do those first 4 problems on the notes. What kind of slopes are these? Review from last class. Don't look back. Don't look back in your notes. Just do them. Give you about 10 seconds. Okay, problem. Okay, fine. I'll give you 15 seconds. What kinds of slopes are these? All right, Luke, give us the first one.
Negative.
Good. Next one, Jason.
0.
Good. Next one, KJ.
Positive.
Good. And then the last one, Steven.
Undefined.
Undefined. Good. Undefined. Yes, sir.
Can number 2 be also called flat?
Nope. 0 is a 0 slope. Now remember undefined. I like to remember it like Spider-Man. Spider-Man climbs up and down buildings, but he doesn't exist, just like that slope on number 4 does not exist either. Right? Yes. She's just saying, yes! That's what she's saying. Yes! Perfect time for stretching. All right, so those are our slopes that we need to remember. So how do we find the slope between 2 points? So we've got 3 things we're going to look at today. This is the first. Find the slope between 2 points. What do you think we should do? That's a great choice. Let's graph those dots. Don't forget that slope is rise over run, points, x comma y. Don't forget, it's a different thing. Remember, a point is a location with an x and y coordinate. The slope is a measurement of steepness. Okay? So there's a big difference. So let's just graph the points like you said. So 2, 6 is here, and then we go up. And I'm going to write that's 2 comma 6. And then our next point, 8 comma 10. Comma 10. Now what do I do? Put the line through it, yeah. Just make sure that you use your straight edge. Okay, and I'll do the best I can because I can't use my straight edge. That's why you use a straight edge. Nobody has an ability to draw a great straight line. So we use a straight edge. I can't. What are you doing? I'm doing. Okay, now what do I do? What does it say for me to do?
Find the slope.
Find the slope. So what should I do now? Find the slope. Rise over run. Rise over run. So what's our rise? What's it? It's 4. So 4. And then our run? 6. 4 over 6 gives us a slope of? Oh, there it is. Thanks, Jory. 2/3. There's our slope. Yep. So how different was this from what we've done so far? It is. It's different. What did we do? What did we do differently? What did we do differently? Name? Yeah, we put the points. We put the points on. We put those points on. That's literally the only difference from what we did last class, right? We put the points on. So let's put the points on again. So I got -3, comma 5. Should be in quadrant, what quadrant is that? Quadrant what? Quadrant 2, good. And then 7, comma 1 is in which quadrant? Now I got a new question for you. What does this, what do the instructions say to do? Find the slope of the line between the 2 points. So I have a question for you. What do we not technically need to do? Say what, Luke?
Simplify.
No, we definitely need to simplify. We always simplify. Good idea though. What are we trying to find? The what? Not the,
Line.
oh, so technically, do we need to draw the line for these?
Yes.
Technically, no. Are we gonna anyway? Yes, we are. But technically, do we need to? Why not? Because what does it say to do? Find the slope of the line. Does it say draw a line, then find the slope? No. On your homework, what does it say to do, like problem number 4? What's it say to do on your homework? Several of you have it out already. See, it says graph the given points, then what? And draw the line. So on your homework, it tells you to draw the line. On these notes, you don't need to. So let's find the slope first, just because I can. So what's our rise? Yes, -4. And our run? You count them? You get -4 over 10. So our slope is -4 over 10, right? Which simplifies to -2 over 5. Now we're going to draw the line anyway because I would like to. There it is. That's my line that I drew last year. Way more smooth than the line I drew there earlier today. Right. Questions? Questions on this? All right, you do 4 and 5. I'll give you like 2-3 minutes maybe. Number 4, you don't even need to graph it, just so you know. Why? How do you know it's 0? Yeah, but I said you don't even need to graph it. So there's no change in y. Remember what our definition for slope was last class? Change in y over the change in x. So look at the y values. Can you see them?
You're just saying
What's the change?
nothing.
So what's the change?
Nothing.
Mathematically? 0. And if it's 0 over anything, slope is 0. Remember how I said we didn't need to graph it? That's why. But no. You're still going to graph it, but notice there's no change in y. So, slope is 0. Right? Because 0 over anything is still 0. Change in y over change in x. And now I'll give you a chance to graph number 5 and get the slope. I really want to get to the tables. That's the big thing for today. The table's on the next page. That's the key new thing for today. So I think that was probably enough time. Notice the quadrants that the points are in. That's important. Quadrant 2 and quadrant 4. Now, anybody see how you could do these? How you could do question number 5 without graphing the line? You do, Kobe? Can you describe it?
Divide the 2 sets.
I'm not sure what you mean.
So like, you know what you make it into a fraction, right?
Okay, yeah.
And so what I think you do is if you have an x and you have a negative x and stuff like that, you add those two together and you keep the negative sign, and with the -2 and the other 2, you add those two together, and then, never mind. I don't understand what I'm trying to say either.
Me either. I got a little lost.
Okay, so for the first one, it's 6 and -2, so you would put -2 as the numerator and 6 as the denominator. And for the second one, it's -6 and 2, and you put 6 on top, I think, and -2 on the bottom, and you would divide them, and you'd get 1/3 of them.
Okay.
1/3, or something like that.
So here's the reason why that works, and that's a cool idea. That's not right, but it's an awesome idea. because it passes through the origin, so it acts like a proportional relationship. So you're thinking of take that coordinate point and write it as a fraction. Awesome idea. That won't work for any other problems that aren't proportional. And since this one passes through 0, it acts like a proportional relationship. It's a great idea, but that doesn't work for all of them. I love that idea though. But guys, remember what we talked about, the definition of slope? What is it?
The change in y over the
Change in y over the change in x. What's the difference? What's the change from -2 to +2? What is the change? 4. What's the change from +6 to -6? -12. So 4 over -12 is -1/3. So just a heads up, that's one way you can look at these. Now, this is the key for today. This is the part that lots of people make mistakes on, okay? All right. Finding slope from a table. So we're going to find our pattern from a table. Don't forget what slope is. The rise over runs, the change in y over the change in x. So if I want to find out what the slope is, what 2 things do I need to find? The change in y. And then what else do I need to find? And the change in x. So the 2 things I need to find are the change in y and the change in x. Not to be confused with proportionality. Slope and proportionality are different. Okay. So what 2 things do I need to find? I need to find the
change in y and the change in x.
Cool, so here we go. Let's find the change in y. How do I find the change in y? Well, let's just look at the different y values. What's the change from 7 to 10? Plus 3. What's the change from 10 to 13? 13 to 16? 16 to 19. So what's my change in y?
3.
The change in y is 3. Now let's do the same thing with the change in x. What's the change in x? Plus 1. Thank you for saying plus 1. What's the change in x from 4 to 5? 5 to 6? 6 to 7. Now, you know what might seem tedious that I'm doing all of them? But what if one of them was different? Then this would be not a linear equation. So we have to check them all. We do. We gotta check them all. So what is our change in x?
Oh no.
It is 1. So our slope is 3 over 1 or 3. Yeah? So if we just use the definition, change in y over change in x, it makes this problem not too hard. What do you think the number one mistake is that people are going to make here? They'll do x over y. Because x comes first in the table, right? So they'll do this and put 1 over 3. Don't be that person. Be the person that uses the definition. Change in y over change in x, not the way it's written. Use this. Remember to use the definition, not the table. The table is just your list of numbers and numbers and letters. You're going to use the definition of slope. You got to find the change in y first, all the time. Okay? Let's get our next one. Let's find our change in y. What is our change in y from 2 to -2? It's -4, right? Because it's going from 2 to -2. -2 to -6. -4. -6 to -10. -4. Sweet. So our slope, our change in y is -4. And now we do our change in x. 9 to 3. What's that change? -6. 3 to -3. -6. -3 to -9. Nice. That's kind of nice for us. So it's -6. Here's where we have to do a little bit extra thinking now. -4 divided by -6. Same sign positive, sign negative. So what do we got here? Positive what? Positive what? Positive 2/3 is our slope. Hey. Now, what note did I write down for you to see? What does that say?
These points are not evenly spaced.
That's okay. Let's do this one together. And you're going to see that they're not evenly spaced, and that's okay. All right? So what's the difference between 3 and 9? 6 plus 6, right? What's the difference between 9 and 11?
Let's see.
Huh. Remember, what did I share with you?
And these are not evenly spaced.
And that's okay. 11 to 15
Plus 4.
plus 4. So these are all a bunch of different change in y's. So I'm going to write them all down. 6, 2, and 4. What do you think we'll be checking? Let's find out. What's the change from 2 to 5? Plus 3. So that's going to go under the 6. Why is it going to go with the 6? Because these are corresponding changes. Okay? What's the next one? 1. That's going to be here. What do you think we're checking? 6 to 8? What do you think we're checking? If they all simplify to the same thing, what do we call those? Do you guys remember? Fractions that all simplify to the same thing, we call them, what is that? Equivalent. We want to check for equivalent fractions. And are these equivalent fractions? Yes. So the change in y over the change in x ends up being the same thing. 6 over 3 ended up being the same thing as 2 over 1, which ended up being the same thing as 4 over 2. So even though these are all consistent, it's okay. Let me show you what happened. So look up at the top right-hand corner of my screen. Okay? See where those points are placed? They're not evenly spaced. But what do you notice about the points? They're in a straight line, right? So just because they're not like this, boop, 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 they can be like, as long as they're all in that same line, then you're good to go. All right? So just because they're not evenly spaced doesn't mean that it's going to be wrong. It just means that you have to check for equivalent fractions. All right? The key is the change in y over the change in x, right? Is this change in y over the change in x the same as this change in y over this change in x? The answer is yes. So it does have a constant slope. What if the answer was no? What if this was a 3? 6 over 3 equals 2 over 1 and 4 over 3. Then there wouldn't be a slope. Why? Because it would go like this. It'd be like beep, beep, beep. It wouldn't be a straight line. Do things that aren't straight lines have slopes? No, they don't. Okay? All right. I want you to do the next one on your own. These are horizontal. Bless you. These are horizontal. Notice this different structure. Careful. It's the same thing, but rotated, right? So what should you do first? Change in y, and then what should you do? Put it over the change in x. Okay, do this one. I told you this is the big thing. This is the big key. We're spending most of our time on the tables. We'll practice them again. We'll practice them again on your homework, and we'll practice them again tomorrow. Backwards. Sorry, my pen was freaking out. Slideshow. All right. And what'd you guys get? Oops. There we go. Sorry about that. Did you guys get 4?
Yeah.
Awesome. Did you try this next one yet?
Yeah.
What did you notice?
That
So there are some notes, some things you're going to want to write down. Okay, I wouldn't write down everything, but what you notice, hopefully when you do what we've kind of been doing with writing down the changes, is that hopefully you've been noticing, did you see that there's a constant change in x, but there wasn't a constant change in y? Notice, subtract 2, add 4, add 0, and add 2. Now, remember, I told you sometimes they won't follow the same pattern, right? And that's okay. Except, what do you notice here? They follow the same pattern. So, which is it going to be? Follow the same pattern or not follow the same pattern? Well, that is not okay. They're either going to follow a pattern or they're not. It can't be like some of them do and some of them don't. What we'll find out about this is if you kind of look at the y values, it actually looks like this. This graph goes like that. Okay? It's called a parabola. But this particular graph does not have a constant change. Remember, change in y over change in x? But it doesn't have a constant change. So what do we call this? This one is not linear. Everybody say not linear. It's not linear because there isn't a constant slope. Remember, to have a line, it has to have a constant slope. If it doesn't have a constant slope, then it's not linear. It's like saying, how can one slope be negative and one slope be positive, right? Does that make sense? Are you with me?
Yeah.
This is the only one that we've had that didn't give us a constant slope. So this one's important, okay? There will be some like this. I think I saw one on your island when I was walking around. There was some options where it said, is this linear or not linear? So this would be not linear because, so there's no slope. It's not linear because there isn't a constant change, okay? All right, last thing. This is super easy. If we remember how to graph a point and how to find a slope, which you guys know how to do. We already did it. So what we need to do is we need to first plot our point. Secondly, we need to do the rise and overrun, get our second point, do it again, and then graph. And we've already done this before. We did it earlier in the year. But let's do it again. Okay. We'll do one together. You guys do one separate. So what point do I graph? I graph point A. What's that point called? It's the origin. So we actually name it A because we're told that it's named A. You with me on that? See how it's named A? And now how do I use my slope to find another point? Well, what does this tell me? This tells me that my rise is what? -3. So what do? I go 1, 2, 3. And then that's my run. So what do I do next? 1, 2. There's another point. Let's do another one. 1, 2, 3. 1, 2. There's another one. Let's do another one. 1, 2, 3. 1, 2. Now, what are we supposed to do? What are our instructions? Draw a line. So, what I drew here should not be dark. That's not our goal. Our goal isn't to have a bunch of stair steps. What's our goal? To have a line. Okay? So these should be nice and light. Heads up. I can actually go backwards too. I don't have to always go down to the right, down to the right, down to the right. What could I do? Up and to the left. You guys see that? Down to the right is the same thing as going up and to the left. So let's get 1 point by going up and to the left. Just practice. So it's left and up. There we go. Boom. Got another one. And we plot that. I'll use purple this time because I haven't used purple in a while. There we go. You guys remember 2 as well. And you'll check it with me in just a moment. See, I told you, that's not tough, right? That's as long as you remember how to graph a point and then what slope means, as long as you remember what slope means, the rise or the run, or the change in y or the change in x. If you can think about it in both ways, it's a lot easier. Now, as you're graphing it, this has a slope of 1/2. Is that a shallow slope or a steep slope? Shallow. And is it positive or negative? No, I'm looking at number 2. Is it positive or negative? So we know it's a shallow slope and it's positive, so it should probably look about like this, right? We knew that this one was a slope, it was greater than 1, but it's negative, so it's going to go like this. Be facing this way. Check yours with mine, check where it crosses the y-axis. Check where it crosses the x-axis, and that's how you can make sure that you're on the right track. That's how you can make sure you're on the right track. Does it cross the x-axis and the y-axis is about the same point?